Hello. Um, Today I'm going to demonstrate how you can do homework 4, how you can do the empirical exercise in homework 4. In homework 4, the data is about the relationship between height and earnings. So if you were taller or shorter than now, then what would be your earnings? What would be the difference in your earnings? Which sounds a very absurd uh, question, but it is seriously studied in economics. So let's think about the data. So I opened this data, and as usual, you have to change the working directory. There are many things going on. Homework. And open the data. So in this data, you can see the variables here. So it has 11 variables and number of observations is more than 17,000. So uh, quite a lot of observations and memory. And The key variables we are going to use in this data is earnings and height. So maybe height is measured in inches, and earnings, I'm not certain how the earnings was measured. Uh, I'm not so sure. So anyhow, it is some kind of earnings, maybe annual earnings or hourly earnings. Anyhow, and we are going to use other than these two variables, we are going to use education. Uh, so let's have a look. Like because I'm not so sure how the earnings is defined, you can just have a look at the data by clicking data editor. Like so, you can just browse the data by clicking this, and then earnings is here. Somehow earnings is several like $84,000 and 14,000. So it looks like the earnings is an annual, so annual total earnings, and height is inches, obviously inches, 60 something, 70 something, 50 something, and education is years of schooling. So completed 13 years, 12 years, 16 years, da da da. So 16 years of education implies finished 4-year college, and 12-year implies finished high school, but no more education from there. And also there are other interesting variables like female, like sex, 0 is female, and age, and marital status, and coworker, no, maybe employer, private company, whether private company or state, federal, local government, and region, northeast, south, midwest, or west, and race, and earnings, height, weight, and there is occupation. I don't know how occupation is defined. Sure. Anyhow, we are going to use one, two, uh, three variables. These three variables. So just looked at the data just to see what's going on. We don't need it again. Close it. And I will show you how we do the analysis. So, so like I recommend you to use this command on to file. So now you have done this 3 times already. So now you should be accustomed to this. First, I'm going to regress earnings on height, and I will use robust standard error option. So I will execute to just to see what how it works. So it works well. We get some result, and it is interesting to see that if you are taller, if your height increases, your coefficient so your coefficient is positive, which means if you are taller, your earnings will increase. and the relationship is the t statistic is 14, which is very big, because if t statistic is greater than like approximately 2, then we say the coefficient is statistically significant, but it is 14, so it's quite huge. Or you maybe p-value, this is the p-value, which is a better measure to see the statistical significance. The p-value is 0, 0.0%, which means it is statistically significant at any significance level. So it is significant at 1%, or like a 0.1%, or cannot is like, so it is rejected even at 0.1%. So the 0 p-value means this coefficient is super significant. And so it is interesting to see the relationship between height and earnings is statistically significant. And in the, you may like in the homework, I explain why this happens. There are some researchers, economists, to study why they have so strong relationship. So one possibility is through nutrition, why, like in their early childhood, or when they are growing up, if they had bad nutrition, then it affects their height, and also that affects their physical development. So physical development and cognitive ability development. So in the end, the cognitive ability development affects the earnings. So the nutrition in their childhood would be the confounder, the hidden factor, the omitted variable we can expect in this context. So to relieve the omitted variable bias from the nutrition in the childhood, we are including education as a control variable. But you may just use regress earnings on height and education, but we are going to use a little bit different approach. We are going to define the education level into 3 different groups. So 3 different groups imply no college education at all, and the first group is the no college at all, and second group is some college education but did not finish 4 years, just some college education, maybe 2-year college or drop out during the college. And the third group is having a college degree. So we are going to define these 3 dummy variables. We are going to define them. Have a look at see what happens. I'm going to use this command window to show you what happens instantaneously. So I will generate a variable no. So no college. It means no college at all. So I will define a new variable no college equals to 0. So if you type this and browse the data, then you see a new variable. It only takes 0. So 0 is because we defined it as 0. 0 is the only summarize. No. Then you will see it's purely 0. Minimum is 0, maximum is 0. Now what we are going to do here is we are going to replace no to 1 if education is smaller than or equal to 12. So education 12 or lower means, so 12 years of education is high school graduate without any college education. So 12 or lower means no college, just maybe high school or lower. And so this is how we define this dummy variable. No dummy variable is defined this way. And now if you summarize the variable again, you can see that out of more than 17,000 observations, the mean of this variable is 0.46, which means 46% of observations fall into this group, have 1. So 46% of observations have no college education at all. And minimum is 0, maximum is 1. So nothing special. And similarly, we are going to define some college, generate sum first, and replace some college to 1 if education is greater than 12 and education is but smaller than 16. So we need to connect them by AND. So there are two conditions. Greater than 12. That means these guys took some additional education after high school, but they did not finish 4 years of college. So they just made like 2 years or dropped out. So, and these two conditions are connected by AND, So if you define it this way, you can see previously when we defined no, there were 8,293 observations changed, but now only 4,443 changed. So this is the number of observations satisfying these conditions. So let's summarize two variables at the same time. So 46% was no college education, and only 24.8% is some college education. Maybe 13 years, 14 years, or 15 years. And finally, we are going to define generate degree. I will define those who have college degree in this way and replace degree to 1 if education is 16 or greater, right? Greater than 16 or equal to 16. And then now you see there are 5,000 changes, and you can verify what happens. And there are 28% of observations in this group. So like this, we defined 3 education groups. But one more remark. So earlier I explained the difference between one equality and two equalities. So I will just show you one thing. Generate like temporary variable. I will define just a dummy variable temp, and I will replace temp to 1 if education equals to 12. So these guys are high school graduates, finished high school having exactly 12 years of education. So there are 6,000 observations satisfying this condition. But so you don't need this variable in our analysis. But what I wanted to tell you here is that I used 2 equalities here, but only 1 equality is used here. The major difference is that this statement, this expression, is a condition. So you are telling the program to check if this condition is satisfied or not. So it is not a definition. It is not an order. You are ordering whether this is true or not. But this is an order. If this condition is satisfied, then you have to define temp variable to 1 as 1. So when you use one equality, you are assigning the value to this variable. So one equality and two equalities are totally different, like understood in a different way by the program. So so it's very confusing. So I'm telling you again. Okay, that is that. Okay, anyhow, we defined. Uh, so so if we don't need temp variable again, so I dropped it. So we have three groups. We have three dummy variables. So we are going to use these variables together. So let's include, like in the regression of earnings on height, we additionally include the educational dummy variables. And using the robust standard error option, you have this. You have this, and you should see what happens here. This is the dummy variable trap that I explained in the lecture. So you are seeing the dummy variable trap. So sum is deleted. I think sum is deleted because it has the smallest mean. So I think that's how theta drops one of the dummy variables. Anyhow, it is not estimated. It is not estimated. It has no result. It cannot be calculated. And compare, in the homework, you are going to compare this earnings on height and no and sum. So I intentionally dropped degree. Degree variable is dropped. Degree variable is dropped, and then sum variable is estimated. The coefficient of sum is estimated, and what is interesting here is some results are different. So some results are different. So these guys are different. These guys are different, but these guys are the same. So some guys are the same, some are different. So in the homework, you have to explain why they are different and think about what's going on. So that is what you need to do in the homework. And so on top of this, you need to do some test, and testing can be done here. Post estimation. So post estimation menu is available here. So this is literally post estimation commands. So when you run a regression like this, in the memory, there are the regression results saved in the memory. So, and some commands require those results in the memory. So you need to do the post estimation commands right after the regression command. So while the results are in the memory. So let's try this. And so there are a lot of different commands, and we are interested in hypothesis testing. So hypothesis testing, and especially we are going to do linear test linear hypothesis after estimation. What we are going to do here is, there is nothing, I think. We are going to use no equals to 0. Add, and it equals to 0. So you may just check the example and one equality. So this will give you one hypothesis, and we will use another. Excuse me. This coefficient equals to 0. and then you get this result. So you are testing two equalities. First equality is beta underbar b means the coefficient beta for this variable. So equals to 0. This is the first equality in the null hypothesis, and the second equality is the beta for some variable, and some variable, and it equals to 0. So they are connected by parentheses, and it understands this and calculates f statistic. F statistic is more than 1300. So if you remember what I told you in the lecture, f statistic greater than 3 is maybe that is the threshold for two equalities case, 2 degrees of freedom, but it is 1300, so it's obviously very, very strong. So the p-value, this is the p-value. P-value is 0, simply 0. So you can see if you can reject or not. By the way, so this is how you use just click menus to do the test. So here you may add more, and you may just disable some or enable or edit. You can just do whatever. So simply you may just use this. You may just try that. So like just in case if you don't know the command, you could use the click menu, but simply you may use this command. So same thing. This is a simplified way to test the same thing. Test no and some, no equals to 0 and some equals to 0. So there are two equalities considered at the same time, and you may do you may define different null hypothesis using the click menu. And by the way, so this like as I said, this test command is working only when or only right after while the regression results are in the memory. So now let's see what happens. So I run a different regression now. So now I don't use no and some variables. Educational variables are not used. And then let's do the same command. It is not working because these variables are now not in the memory. So the memory does not have, memory only has these variables. So the previous command does not work. So okay, this is what you need to do in homework 4. And it's a long video. Sorry about the long. I forgot to stop the video. And in the next video, I will give you and in the homework, what you need to do next is to combine these 3 regressions. We considered 3 regressions. First, earnings on height without any control. And second, we considered 2 different ways to include the education dummies, this and this. So you had 3 regression results, and you have to make them into one regression table. It is very annoying to do it by hand. Like you need to copy the numbers to Word. So in the next video, I will show you a short command on Stata to make a table. So it will be very helpful for you to make a nice looking table without much effort. Okay, see you later. Bye.